Okay, cool. It's recording now. All right. I'm just going to share my screen. Yeah. Can you guys see my screen?
You can see it.
Yeah, cool. Okay, so hi everybody. I am Raghavi Krishnan and I am a graduate student majoring in supply chain management at the University of Dallas. And thank you all for being here with us in this webinar, Supply Chain and Circular Economy with Deborah Dull. So let's just, so the agenda for today's webinar is, I'm just going to introduce Deborah and Supply Chain Leadership Council. And then I'm just going to give it away to Deborah to talk about her stuff to amuse us. And then after that, we'll open up with Q&A. Yeah? So, yeah. So Deborah is a supply chain leader, and she's currently heading products at GE Digital. Previously, she was with the Bill and Melinda Gates Foundation, and she was instrumental in laying their health supply chain. Oh my God, how cool is that? And before that, she also was with Microsoft with their retail channel in Europe. So anybody who knows Deborah knows how much she loves inventory. Not long ago, I happened to listen to a podcast where where she was talking about her love for inventory, and she compared it with a pipe, and really amusing, really cool stuff. I'm going to let her talk about it more. She also has co-founded this podcast called Supply Chain Revolution with Sherry Heinisch. And they talk about really cool stuff about new age supply chain, new supply chains. That's what you guys call it, right? And also she has her own blog called Circular Nomad, where she tries to associate circularity with with the places she travels. So again, really cool and inspiring stuff, especially for us as students. I mean, this whole thing is really something all of us want to do, you know. So yeah, that's about her. Um, so yeah, Supply Chain Leadership Council, we are a group of graduate and undergrad students at the University of Texas at Dallas, and all of us are majoring in supply chain management. We are looking at ways to bridge the gap between academia and industry by having networking sessions and industry site visits. Obviously, we haven't had any in the past few months because of the pandemic. But we are looking at helping students to interact with industry professionals and learn more outside of the classroom. So we also host business case competitions, and we have a new mentorship program. Recently, we just started it, where we have partnered with a couple of mentors from the industry to help out students with the major that they want to, with the how to navigate with the job search and stuff like that. So that's about us. So I'm just going to let Deborah do the talking, and yeah. Should I stop sharing now, Deborah?
Yes, please. And if you could make me the host.
Okay. Hold on. Let me see how to do that. Just give me a second.
Actually, I don't think you have to. Let me try to do this.
And I did it.
Oh, great. Okay, perfect.
Yeah. I made
okay. Are you seeing the screen?
Yeah, I can see.
The PowerPoint that just has a title screen? Okay, perfect.
Yeah.
All right. Thank you so much for inviting me and doing a reschedule. I had a family emergency earlier when we had the schedule, so thank you for being so gracious in the reschedule. I am going to talk to you today about two concepts, value and waste. And these are, of course, areas that we study in supply chain and we know a whole lot about. As I started to learn about and study the circular economy, I was just flabbergasted that more supply chain professionals aren't in these global forums as we talk about how to transition to circularity. So I hope from this, you can take away a few next step areas and hopefully focus your study and give feedback to your professors to incorporate this into your curriculum. So in process, which we all think about in supply chain, we have value. and we have waste. And of course, our whole careers really, we're going to spend looking at ways to increase value and decrease waste. I first learned about process improvement when I studied supply chain at university, but I think it was probably parts of my childhood that helped me learn that there can be value in waste. I grew up in a fairly rural area. Both my parents grew up on farms, and we had a few small areas to grow food, and we composted. So from an early age, I learned which food scraps we could compost and which we couldn't. And then that compost went into the garden, and the garden grew our food, and I had my first lesson in circularity. My father was a woodworker and built houses and furniture and boats out of wood. And when I was small, I sometimes got the wood scraps to play with. But more often than not, he found ways to reuse the different scraps and build something new. So another lesson in circularity. In the time that we have together this afternoon, I want to explore value in waste. Just admitting people here. Up until this point, as a global economy, we've seen something that looks sort of like this. Customer, supplier, customer, supplier, customer, supplier, and so on. It happens in a line. And along that line, we find and eliminate waste. The circular economy says there are more opportunities to make money than what we're doing today. It doesn't have to be a line, it can be circular, or in my artistic rendering, it can be loopy. The circular economy says there is more value to be had. Today we have waste, tomorrow we have value. So, what is a circular economy? In order to tell you this, I'd like to tell you a story. We'll cover 4 major topics today: the elements of the circular economy, technologies of the circular economy, the supply chain impacts of the circular economy, and getting started with circular economy and supply chain. After each topic, I'll pause for questions so that we can all be on the same page together. So, starting with the first element, where did the circular economy concept start? And this story starts on a Christmas Eve about 10 years ago off the coast of Australia. There was a solo sailor who's won many global awards called Ellen MacArthur. And she was alone on her boat doing inventory, my favorite topic, as you already know. And she had this aha moment. She realized that just as the supplies on her boat would run out, would just barely get her back to home, she realized that the supplies on the planet were also running out. When she got back to the UK, she found, yep, this is true, the items in the planet used to run our global economy are in fact running out, and at a pace quicker than she anticipated. And so she started learning more about this topic and learned about another Christmas Eve about 100 years earlier in Geneva. So this is Geneva, and imagine somewhere on a little side street on Christmas Eve, there was sort of a secretive business meeting among business owners. They all had the same problem. Their products were too high of quality and were lasting for too long, and they were actually going out of business. And so I'm gonna have you guess mentally take a 10 seconds and guess, what could this product possibly be? Maybe you already know the answer. It's actually the light bulb. And at the time, light bulbs could last 2,500 hours, but even though it was becoming more popular, not popular enough to sustain the growth that they all needed. And so they all agreed that day to cap the hours to 1,000 hours, so from 2,500 to 1,000 hours of the light span. And if they had gone over this, they agreed to fine each other. The importance and significance of this meeting is it's the first known meeting of planned obsolescence that we have. So in a linear economy, we basically produce trash. The whole idea is that we know this is going to end and the consumer has to buy another one. This came just 2 years after Henry Ford coined the term mass production. And since then, for the last 150 years or so, we've gotten really good at making items in this linear economy. And of course, this goes like take something out of the earth, make it pretty efficiently, and in the end, we waste it into landfills. And from this mass production, something actually pretty tremendous has happened. We have what I call mass ownership. The style of the linear economy has allowed the middle class to grow. And this middle class then can afford to buy more items. And so it's not a total loss. We've gotten tremendous global growth from this type of a global economy. But there's also a downside. all these items that we have aren't used. So for example, if we take the idea of a car spending the majority of its life parked, instead, these days, we often just take an Uber. So instead of buying a car, we buy transportation. Let's take a look at another example that comes from my world, the industrial world. GE realized that airlines don't actually want to buy and maintain engines. What they actually want is time on the air. It's called time on wing. And this is important because assets and machines are smart now. If we can combine sensors with IoT, data science, and a bunch of math, we know more than we ever have before about this engine. We know about humidity, altitude, pressure, and smog, and how all of those impact the life of this engine based on all the other engines that we have sensors on. And so by that, we're able to get smarter about all the different machines that we've got. But this concept, if we go back to the circularity, really started a good example in the 70s in Denmark. And this is called the Kallenberg symbiosis. This started because all these different factories that are next to each other all had the same challenge of finding fresh, affordable water for use in their production. You can see they're surrounded by water, but it's salt water. And so they joined together to actually co-locate and share water. What they've done now is actually progress to different types of materials, energy, etc. So you can see the 3 different types of flows and the names of the companies that are still doing this today. By setting up collectively with each other, they save $100 million a year. Maybe for these companies, that's not a huge amount of money, but it's still $100 million a year. And more importantly, these days, it's mitigating the risk that they have at availability of these materials and resources. So we just talked about smart assets, and now this will be the basis of a smart process, which we'll come back to in a little bit. All right, so in a circular economy, there's 2 types of materials. Let me just admit a couple more people here and make sure everybody's in. We have renewable materials and we have technical materials. Renewable materials, think about it, anything that can go back into the planet.
I think that is what Sri Harika, she, like when she uploads the
guys,
zip
can you put yourselves on mute?
That's what's get added automatically. But we can do this manually. So who is she?
Is there a way to put everyone on mute?
Let me see if I can
just trying that. Oh no, I think Deborah, you can do that now that you're the host.
I'm attempting to, I just can't find who it is.
I think it's Karandeep.
Yeah, it's Karandeep.
Great. Okay.
Sorry,
now,
thank you.
No problem at all. Let me go back to this. Okay, perfect. All right, so renewable materials. That goes back to the biosphere. So think about heat, think about composting, think about water. Technical materials, on the other hand, would not go back to the biosphere. They've been processed in some way, but still hold value. Think about like metals or plastics. So we have 2 types of materials, and they circulate or loop through the economy. And these can be big loops or small loops, and it looks something like this. This is called the butterfly diagram from the Ellen MacArthur Foundation. On the left side, you'll see those regenerative materials, and on the right side in blue, you'll see the technical materials. The idea is to have an item stay as itself for as long as possible, and then keep the loop as small as you can for as long as you can. So in this case, for example, you'd want to use an item as long as you can, repair it, maintain it, share it, lots of different activities to do before we get to recycling. One of the common misconceptions about circularity is that it's just recycling, when in reality, recycling is the loop of last resort. There's a lot of other ways to add value with the product before you get to recycling. All right, these are the 3 principles of the circular economy, and we'll go through these a little bit more later on. Circular economy says that organizations that anchor in these principles will reduce waste and be more profitable. So design waste out from the beginning. This is really during, if you're gonna redesign a process or set something up to begin with. The second is keep materials in play. So for example, my clicker I have here, we want to have this be a clicker for as long as possible. So let's say I don't want to do presentations anymore. The circular economy says I should give this to somebody else or even lend it. So if I don't use this 100% of the time, I should be lending it to other people so that its utilization can be as high as possible. The last principle then is to regenerate natural systems. And essentially what this says is, sorry, just admitting more people, is if we actually restore natural systems, economy will grow and we'll have more items that we can use to run a global economy over time. I'm just muting the people who just came in. All right, so this one is kind of interesting. And one of the last concepts to really think about is that the circular economy decouples growth from the resources needed. And this is what it looks like. So a linear economy over time, we can see commodity prices and the price coming down. We've become more and more efficient, as we can see over time, lean management, et cetera. However, as we start to realize that our resource base is running out, we see the price of commodities has climbed back and kind of undone all of the hard work we've been doing on process efficiencies. On the other hand, we can start to decouple this type of commodity pricing from the money we can make in the business. Being in supply chain, we'll be acutely aware of cost per unit and variable costs throughout your career. And right now it's assumed that that variable cost is tied. So it might cost 45 cents a unit, no matter what, to build a unit. But the circular economy says, actually, we can start to decouple that. And as you don't start from scratch every single time and you want to make an item, then you get actually faster and cheaper because you don't have to start from scratch every single time. All right, and this is the slide to show that circular economy projects are active all over the world. There's a really interesting organization you can join called the Circular Economy Club. It's free to join, and actually Circular Economy Week is coming up at the end of October. And so you could see what's happening in Dallas and join virtually, or join anybody's around the world. Before I go on to the next section, are there questions on the element of the circular economy or the concept of it?
Hi, could you please rename the organization that you just told about?
Oh, the Circular Economy Club.
Okay, thank you.
Yeah.
I think he was also referring to the organizations that are currently implementing circular economy.
I can't name all those. That's all these.
Oh, okay.
I'm not going to be able to tell you who all of them are, but you can. I'm happy to share this after, or I think you can actually find this probably on the Ellen MacArthur website.
So I have a question.
Sure.
So previously I did an internship with Lowe's at their corporate office, and there was a whole team there dedicated to what was called reverse logistics. And reverse logistics is basically the process of if somebody returns an item to a store, that item gets sent back through the supply chain. So how does that kind of affect this process? It's not quite recycling, but it's not quite going back to customers directly.
Sure. So my own perspective on this is that in the next 5 to 10 years, there will be no such thing as reverse logistics. It'll just be called logistics because we won't be on a linear consumption-based model. We'll be on a circular usage-based model. So in the case where a customer, something has broken, there would be a repair area or a material reuse area rather than shipping it all the way back to what's typically done through a centralized returns kind of like repair and evaluation center, which is how most organizations do it. But I see that whole process shifting away actually in the next 5 to 10 years. So it's there, it's related, you're right. But I do see that to be an area to be fairly disrupted in the future. Okay, let's go on to the next one and you can think about questions and I'll take those again at the end of each section. So again, we go on to value and waste, these two concepts we're looking at. Now we've looked at the elements of the circular economy, so let's talk a little bit about the technology. Now, purists will say the technology is not required to reduce and minimize waste, but it sure can help. Some of the articles that are out now talk about how Industry 4.0 will bring AI to replace the need for humans, et cetera. I'll address that. And the circular economy, the way it works, means that actually more jobs will be created. So an interesting one for you to think about. So we'll have a look at that. I have a working theory that the circular economy is not possible at scale without the technologies of Industry 4.0. So let's remind ourselves really quickly, what is 4.0 with the world's fastest reminder of all 4 industrial revolutions. Letting more people in. Okay, so the first industrial revolution, 250 years ago, was all about steam and machines. 100 years after that, and I'm just going to mute folks who just came in. 100 years later, we get to the second industrial revolution, and that's about electricity and mass production. On the ceiling of this room, you can see all those light bulbs that were lasting too long and led to that clandestine meeting in Geneva. 100 years after that, we get to the 1970s. This is the third industrial revolution, or the digital revolution. This was about robotics and automation. Now, just 50 years later, we're in the middle of Industry 4.0, and of course, you know a lot about this. The sophistication of technology is high, the cost of sensors is low, and we have more data than we ever have before. We live in a connected, smart world. I talked about smart processes earlier. If we think about this, if we want to, as supply chain professionals, to find and circulate materials, and that becomes a new type of marketplace, we need to know a lot about those materials. Today, this is done through mining. Tomorrow, it will be done by understanding what's already been mined and made into some object, something that's already detached from the planet. So if we want to find waste today, we have to look, we have tools to do that. So as we look at how to reuse waste, we first have to find it to begin with. And of course, we know that we could do something called go to Gemba and observe the process. Gemba is a term in Kaizen. That means going to the real place of work. You may or may not have come across a value stream map in your classes. How this essentially works is we walk the process. It used to be with clipboards and stopwatches, and it may still be like that in some cases, but some of processes are moving so quickly that we can actually get kind of machine readouts to know how fast they're moving. You map 3 different items. You map materials, you map information, and very often you map financials as well. And you can see there are some basic KPIs like lead time, work in process, etc. So we know that we can use this type of a tool to find waste. Now we imagine having to do this for every single process all over the world, and it gets rather intimidating. So we can imagine using something like a digital value stream map. And this is something that my team is working on at GE Digital. So as we think about what can a value stream map do that a traditional value stream map cannot. First, what this one can't do is go to Gemba. So a piece of technology is never a replacement for actually going and looking with your own 2 eyes. It can't talk to people, understand why a process is hard or not followed. It can't observe the human element of these processes. So it's important to always go and look yourself. But after you do that, then you can connect the process into a framework like this, and then we can find waste, identify waiting times, and see bottlenecks. Instead of just one bottleneck, which is often what you get with a value stream map, with technology, we can look at all possible bottlenecks. So we can have a really kind of a smart future in this case. So as you think about these, one of the elements that's captured in a value stream map is the actual waste that comes out of each process, physical material waste. Imagine instead of saying each step here, we have waste coming out, we flip this whole thing on its head and we say, the waste that's produced actually will become a new type of value, and there will be new types of customers for that value. The next one I wanted to talk briefly about is this fear that AI is going to take our jobs. I doubt that any of you have this thought, but just in case, the circular economy says actually it's cheaper to create jobs in a circular economy than it is in a linear economy. So running through quickly, an example, this is from an author called Walter Stahel. He's a tremendous researcher in this space and started looking at the original concepts of circularity called a performance economy back in the 60s. All right, so if we think about a new way to define what good looks like, we always, of course, have money costs, money inputs, material inputs, and we have labor inputs. And we can create our KPIs for each one, value per weight, labor per weight, and cost to create work. And these become really valuable inputs as we look across a whole company or across a whole economy. Now, what the circular economy says is, let's take a comparison of remanufactured versus new. So this is an example of a car. The labor needed for a brand new car is going to be 40 hours. Remanufactured is 120 hours. So we at first think, oh no, everything about remanufacturing is terrible because the cost must go up significantly because the cost of labor goes up. Well, hold on to that thought. The next item is material input. So from a brand new car, you need 1,600 kilograms of materials. But for a remanufactured car, the idea is that you only need 20 kilograms of material. And this is brand new material. And of course, because you're already starting with something that exists, you don't have to get all the metals to make every single component from scratch. You just need to refurbish and upgrade a few different areas. And then the absolute dollar cost, in this case in euros, for a brand new car, 30,000 euros, and for a remanufactured car, just 10. So let's look what it does to these metrics. You can see the comparison of the value per weight, the labor per weight, and the cost to create work. Cost to create work is really where the takeaway is on this slide. Remanufactured, 80 euros per man hour, I should type person hour, against a new car at 750. So the big takeaway here, of course, this is a very simplistic example, but the idea is, although labor went up, the overall cost of the car went down. You may be able to pay sell a refurbished item for as much as you sell a brand new item. So actually, as a company, you're doing really well. So some interesting different ideas to explore. Before I move on, I know that was relatively quickly, but thinking about the idea of smart processes, sensors, any ideas, thoughts, or questions on that? All right, we'll go to the next section. So value and waste, of course, are two topics for the day. We have looked at the elements of the circular economy. We've looked at the technologies of the circular economy. In this section, we'll start looking at the supply chain impacts of the circular economy. And the circular economy starts to shift some of the supply chain practices that you will get to know very well soon. So when we think about supply chain flow, we think, what flows through a supply chain? And I already gave you the answer earlier. The first one is materials. And so this is the one area that I often do talk about, reverse logistics, per the earlier question. And besides reverse logistics, which is a small area at the end of the supply chain, most of the focus of supply chain is a forward flow in a linear model. As we transition to a circular economy, materials will need to make sure that they can flow in all types of directions among all different nodes across the supply chain. The supply chain hierarchy that we have of customer supplier, like I showed, is no longer relevant because this location needs to be able to ship to all different types of locations, even if there isn't a formal business relationship between those two locations. For example, consider plastics from, let's say, water bottles found on a beach. And they're collected, they need to be sent to a processing facility, made into pellets, resold as a raw material, then that goes on to make fabrics or shoes or more water bottles. That first part of finding that material is really the only part that's different from what we do today. So all in all, we're actually getting pretty good at how to do any-to-any movements, which is not how it was 10 years ago. All right, the next element that flows through supply chains is information. In general, information moves okay up and down supply chains, and the level of automation depends on how integrated a supply chain is with our different partners. However, even though we have the technology foundation to run these large supply chains, often supply chains are still run on email and spreadsheets. So that's one element to address, but this isn't even really the hard part. The hard part is the ERP systems that we use to have our supply chain sit on today don't like to loop or bend. It can be really tough to even process anything that happens out of process, which we know will happen, can be tough. And here's the kicker. An ERP upgrade often takes 3, 4, 5, 6 years. Gartner, the analyst company, gives supply chains just 10 years to become circular. They said 10 years from now, supply chains cannot produce waste. McKinsey, another analyst, gives us just 5 years. So if we think about normally taking 3, 4, 5, 6 years to do a major ERP upgrade, and we only have 5 years really to make this happen, and we don't have the technology ready for it yet today, we've got our work cut out for us ahead of us. All right, and the last item that runs through supply chains is financials. I predict that the habits we have around financial flows will become quite complicated. New financial relationships will emerge. So if you think about the idea of a Kallenberg symbiosis, like I shared, but instead of co-located, they're going to be regionally located. And there may be an available resource over here that this company needs, but they're not already trading partners. Typically, to establish the idea of a trading partner might take several weeks to get negotiations and all the legalese figured out. However, I predict that this is one place where blockchain solutions will actually help us. Because you can have non-trusting partners and who need to exchange financials, the idea of crypto tokens could be quite interesting here. So I predict we'll see some movement in this space. So when I think about supply chain flows, of course, I think about the value stream. And we've already talked about value stream mapping, and we've looked at kind of a smart process. That type of a smart digital value stream map, I think, can become the basis of a process digital twin. So if you think about sensors and advanced technology telling us when a machine like an airplane engine needs maintenance, a smart process also can tell us when it needs maintenance, which is to say, if a certain process step continues to fail over time, then that should be some sort of a flag, and eventually the idea of self-healing or self-driving supply chains will emerge. So if we think about changing the idea of a value stream map, and when we think about value stream maps today, of course, we think about waste. So let's think about waste and our habits around waste and challenge those a little bit. So when we think about lean or Kaizen, maybe you've had a chance to be part of a Kaizen event already, but in these events, the focus comes down to waste. Wasted time, wasted money, wasted materials. Lean teaches us to reduce the amount of waste produced, of course. And we can start to relate digital lean, digital Kaizen, and use some of those newer technologies to help to accelerate these transitions. And this is, of course, a really important concept for the circular economy, to reduce the amount of materials needed, and the waste is so powerful because it reduces the amount of byproduct produced during manufacturing. If lean is about finding and eliminating waste, then circularity is about finding and monetizing waste. Process waste can be monetized. The process can be a manufacturing process or a consumption process. For example, Ford, several years ago actually, realized that they needed to do something about plastic in their cars. Each car that they produce needs 300 pounds of plastic. Then what they did is to scan the environment to say, where is there a biomaterial that we can use as a basis for bioplastics? And they found Heinz ketchup. Produced a tremendous amount of waste from seeds and stems and skins from tomatoes as they make ketchup. So that's one example. Industrial waste in the US alone is a $60 billion a year industry. Or if we think about it, if you could monetize all the plastic garbage around the world, then you could buy Walmart, Apple, Microsoft, Amazon, Facebook, and a couple others, as you would have $7 trillion. Or we could start with a more reasonable goal of exploring selling processed byproduct. And of course, we know this happens today. Oil companies sell the hydrogen created by oil refineries. Meat processors sell scraps for pet foods. So we start to see this type of selling byproduct, which will be amplified in years to come. So imagine a world where waste was seen as something of value, where we would locate specific types of waste, where waste would arrive at a factory as a raw material. And it starts to sound a lot like my favorite topic, inventory. Think about waste as inventory. Think back to that Kallenberg symbiosis example where inventory is swapped among partners. We've done this for a long time for different types of inventory. So for example, spare parts are used to help elongate the life of a product, which is one of the core principles of circularity. But imagine this for different components harvested at scale from waste and waste streams. Imagine the impact that would have on the upfront product design. And this is where we see products becoming more modular so they can be repaired more easily. Imagine applying inventory waste to managing waste, inventory logic to managing waste when these processes are far apart from each other. How do we manage the quality, quantity, timing, and location of all the different materials we have? I mean, look around you right now. In a circular economy, every single thing you see today right now in front of you becomes feedstock to make something else in the future. So as supply chain professionals, if our job is to figure out which materials go where when, then we need to know where everything is today. And for this type of complexity, again, I would turn to a digital supply network or a digital value stream map. So we think about this ecosystem where you have sellers of waste and buyers of waste. If you think about a materials exchange, some sort of a marketplace that connects these systems together, and I'll give you an example of one later on. This ecosystem of each supply chain would potentially become very large, very complex, depending on the dynamic nature of the waste supply. So we've talked about waste as an output. Let's consider waste as an input, which is all about supply chain. So today we have a specific way to consider quality, quantity, cost, timing of raw materials, and that's done by our sourcing managers. Most of our sourcing managers spend time following commodity markets. In the future, those markets that exchange finite resources will have less and less traffic as virgin materials are depleted and run out. Instead, I imagine a new type of marketplace that's able to forecast waste, the quantity, quality, location, availability, et cetera, and to be able to create these value exchange markets based on future state waste. And again, imagine that industrial symbiosis example pulled apart geographically. As one example, last year, 25 companies came together to form an Ocean Plastics Alliance to figure out what they could do with this type of waste. And to me, it's an early signal that these waste markets will be emerging. I have a research question that I haven't found a good answer to yet. So for you master's students, maybe you can take this on. Thinking about a circular economy challenge, and I wonder how much of it is just based on supply. How much of the circular challenge could be solved if every supply chain switched tomorrow to using only recovered materials, no longer using any virgin new materials? This would mean immediate changes to the way the supply chain functions. So what if we all just focused on sourcing secondary materials that have been used before? I think the market would correct itself within 6 months, but we don't have the ability to do A/B testing here. But the idea of secondary materials as a service, I think, will emerge as a new type of industry. All right, one section after this, but any questions on what I just covered?
So I've heard that homes built with reclaimed wood are actually nice and long lasting, and that's just one example of how something that was secondhand can actually be used to build a completely new product. So do you have any other similar examples of that?
Of the built environment, or you mean generally?
Generally.
Like construction like that? Sure. I mean, we can look at clothing, for example. Lots of companies are now making shoes, leggings, hats out of plastics. Plastic is an easy one to start with because there's just so much plastic waste. If you have been to IKEA lately, there's a potential that instead of styrofoam, you're using a molded type of packaging that is made from mushrooms, an agriculture byproduct, and they push it into a mold, and these spores grow within about a week. It's as cheap and light as styrofoam, and then it composts within about a month. Just saw really interesting, there's a company called Husky, which makes reusable coffee cups out of coffee grounds. And so the idea of a husky. There's an interesting consumer food product that actually uses spent grains from a brewery, and they make it into like a snack bar, and it tastes delicious. Several others. So there's lots and lots of examples. A good place to start is the Ella MacArthur Foundation website. So that solo sailor at the very beginning of the year is now a dame in the UK, and she has a foundation. And they've got a really fun learning hub that you can zoom around and see different types of examples like this. Okie dokie. So this last section, how would a supply chain get started on switching waste streams to value streams? If you've been paying attention, then probably this first step will not surprise you. We need to find the waste. So before we can actually make value, we need to figure out where the waste is from. And we can have a couple of examples. This is from the World Economic Forum of 4 different types of materials. You can scan through these. They have something called golden oldies, like PET plastics, metals, etc. High potentials with new types of chemical research happening in material sciences, rough diamonds, and then future blockbusters like 3D printing and bio-based materials. Especially, I think bio-based plastics are going to be a huge influx as we go forward. So how do we find these? Of course, we need to be able to map the value stream in some way. So it could be digital or maybe even old school by hand. And in between here, we have this concept of fugitive value. So instead of calling it waste, see if you can challenge your professors and say, it's not called waste, professor, it's called fugitive value. Everything has value in a circular economy. The challenge is where it is where we don't want it to be. So as plastic, for example, it's not bad by itself. It's bad when it ends up places where it doesn't have any value, like the ocean or a landfill. And so it becomes fugitive. Once we find the waste, of course, then we want to reduce it. And I'll run through 3 types of the 3 moves, as they say in Kaizen. You've probably heard about the first move, which is the 7 wastes that typically happen around a physical operation. And for this, of course, we would want a value stream map and some sort of cool technology. So I think in the future, actually, as the cost of augmented reality glasses comes down, we're going to start seeing more and more use of augmented reality in industrial operations. And in this example, we can see very easily between these 2 assets look quite similar to each other. One is fine and the other has a systems error. Similarly, as you scan across a factory floor, for example, you could see a virtual Kanban going off for too much inventory. The second type of waste is called Mura. And I flipped past it a little too fast there. Mura is waste caused by unevenness or variability. And you probably have learned already that supply chains don't like variability. We like to be constant. So it can be caused when standards are non-existent or not followed. It can be caused when production has to ramp up to meet sales targets, which forces the sales team to rush to fill orders when in the first place kind of ends up as a push instead of a pull. Defects that are manufactured into products, all of these are types of waste. And we have different ways, of course, internally, and you'll see around the industry, lots of ways to address finding variability in a process. For the last waste, we'll look at MORI. MORI is what happens when you overburden staff or equipment. And this helps to tie into that circular principle of having an item remain as itself for as long as possible. So when we look in the industrial world and we're running these machines really hard, we want to make sure that they can last as long as possible. All right, so once we find the waste, reduce the waste, then we're going to start predicting waste and waste flows. So this really starts to be able to get into the math. And again, when we need to know all these information about an item, location, quality, purity of a material, then we want to reduce the amount of material that's used, and then we want to be able to predict what's happening. And this is where we'll start to see digital twins. We have digital twins of assets more and more, but we'll start to have the digital twins of process. And Deloitte has done some interesting work on sort of the digital twin kind of approach. All right, once we can predict it, then we're in a good position to be able to prevent it. So this gets into a lot of math. So as prevention and optimization, Ideally, you'll be able to get into a lot of this in some of your classes, but it's really rather fascinating as we start to take different elements into the optimization models that we're building to account for circularity. And of course, in reality, there's a loop between predicting and preventing and predicting and preventing. Then, of course, we want to find these new customers. So value is defined in the eyes of a customer. So with new customers come new types of value, or flipped, with new types of value, you'll be able to sell to more customers. And this is when we can start thinking about the marketplaces like I had mentioned before. So a couple of examples of marketplaces that are happening today, which is quite interesting to go and Google. And then, of course, we need to circulate. And this is my squiggly line here. So we can think about the different types of loops that happen in a circular economy. So the first one is called narrowing the loop. And this is when we want to reduce the amount of material that's even needed. So it could be the material, it could be space, it could be energy, it could be water. So just reducing the amount of resources and material to make the same item. Then we can get into what's called intensifying the loop. This is around the sharing economy. So if I were to share my clicker, like I said earlier, or as we think about even spare parts, for example, we're starting to see some sharing around those. Slowing the loop means to really slow the life of a product and make it last as long as possible. And of course, closing the loop where materials are used again. So an example of this is a bit hard to see, but what it gives you is the idea of steel used again, so a closed loop idea. And there's two products here, a screwdriver and a car that uses steel. And in here you can see sort of an approximation of a bill of materials, and steel is highlighted on the different elements where it goes in. This would be picked up by your value stream map. And as you disassemble this, if it was built properly modularly, we'll also see where steel comes out the other side on the value stream map. Then the steel can be taken and reprocessed and brought back into a steel's commodity market. But of course, you'd want to have the items remain as themselves for as long as possible. All right, so one to the other. I will give you these two examples, linear economies across the top, circular economies along the bottom, and the idea is the same. So we want to make sure that we reduce the amount of materials we need to design out waste from the beginning, allow materials to circulate, and again, regenerate the natural systems. And if you do this, your operating costs will fall and your revenue will increase, and we know that that means more profits. So with our time together today, we covered what is a circular economy, the technologies of the circular economy, value streams of the circular economy, and getting started. And you've seen, I think, that circularity is actually a really nice extension of lean or Kaizen principles. So as you encounter those classes, you should be able to tie the dots on this one. And we found that waste still has another life in it. This is an example of plastic pellets, and can become a new type of value stream. This is that example with Ford looking for different plastics for their cars. And we learned in a circular economy, there is no waste. But of course, we know there's always waste. So we'll say there's no wasted materials. Again, check out the Ellen MacArthur website. They've got a lot of really interesting resources. And I'm happy to take any questions you've got on this.
Is there much of a difference between circular economy and sustainability? Is circular economy a part of sustainability, or is it the same thing?
Yeah, really good question. I'm going to stop sharing my screen so I can see all of your faces again. A couple of your faces. I think nobody's on video actually. I see 4 people
this
on video.
Yeah, I asked the question.
Perfect. It's a good question. So typically with sustainability, you'll see 3 factors, especially as we think about sustainability in supply chains. So you'll have the environmental eco part, the ethical part, and then economically, financially sustainable, right? So we have 3 components. Circular economy really looks at the environmental piece and the economic part and bring those 2 together if you imagine a Venn diagram. Technically speaking, circularity doesn't solve for the ethical elements of supply chain. However, if a supply chain is more locally based, so you're finding, transforming, and using materials locally, it's a, better ethical practices will be happening when it's kept closer to home. And so that's typically the difference between the two. I'm sure there's circularity folks who would argue that ethics are definitely part of it. I say it's a byproduct of the focus of the model of a circular supply chain.
Thank you.
And there's
Thank you
another
so
question
much.
here.
Deborah, we have a
welcome.
question in the chat. Do you want to take that
I
up?
was just going to start reading it. It's long. What about the waste that already exists, not the ones we're creating now? For example, read about the ocean plastics program by Dell, using the plastics they think are going to be dumped in the oceans and not the ones actually in the ocean. Yes, I mean, ideally nothing ends up in the ocean, right? That would be the ideal state because we're going upstream to solve the problem. The company that I know is doing this is a company called the Plastic Bank. They are partnering with governments in frontier markets and treating plastic like cash. So they're saying, what if we treated materials like money, because it is, but have some bank where these materials could be brought for cash? It would look kind of like a recycling center maybe. And then they're partnering with larger organizations to be able to use these. So super important that we go upstream and turn off the valve that's causing the problem on these materials. Fact is though, there's a bunch of garbage in the ocean. There's also a lot of garbage in landfills. And I predict that in the next 50 years, we'll be mining the landfills because plastic doesn't break down, metals don't break down. And we're gonna be out of metals inside the earth, like gold, for example. There's going to be none left in 50 years. So I predict, kind of like WALL-E. I don't know if any of you have seen that movie. If you haven't, definitely watch it. But how like little robots go roam around to find little items of value. And I think that's going to be what we're going to be forced to do.
Got it. So, but is there any company that is actually using that plastic that is being that is already in the ocean to
Oh,
make
yes.
any of their products?
Oh, yes. So Adidas launched an entire line of clothing, leggings, hats, shirts. Procter & Gamble, easily using ocean plastics. They have it on the front of their little logo. So ocean plastics are absolutely used now. And frankly, there's like a marketing angle to it as well. But there kind of has to be because we have to do something. Like we've got to get that cleaned. It's like 5S and Lean, right? You have to clean up the current working space before you can go into process improvement.
Got it. Thank you.
Mm-hmm.
Hello, Deborah. I'm Kunal.
You're a little bit quiet. I don't know if you can get any closer to your mic.
Is this better?
It is, yeah.
Okay. So hi, Deborah. I'm Kunal. Correct me if I'm wrong. What I've understood from your car example that you gave in the end is that the output from the same company is used within the same company, is it?
In some cases, that would be pretty ideal, actually, for the same material to be used in its own supply chain. It doesn't always happen like this, though, and we see supply chains sharing materials. So both will happen. I also predict that we're going to have like in-network and out-of-network trading partners for be another group of partners in your same region, though, that if you've run out of steel or plastics or whatever new types of materials we see in the future, that you know where you can go to get those other types of materials. So I see both happening. With a company like GE, we were at one point, maybe still are, the largest internal supply chain in the world with 400 factories, and we use almost all of the elements on the periodic table. For us, we could sustain, very likely, an internal circular economy, but most supply chains are not that large, so very likely we'll see some swapping happening.
So companies, these large giant corporations that that stick to the traditional supply chain of make, use, and throw, if they want to implement circularity in their supply chain, I understand this is, but it depends on what company it is. But on a high level, how would they start implementing, like changing from the traditional process of make, use, throw to make, use, and reuse?
Sure. So the steps I laid out are the ones I recommend. The first one is that value stream mapping. It's a pretty traditional way. It's tough to replace when you don't know what you're using today. As you go through, most supply chains don't account for items like supplier packaging, but they have to be on the value stream map in order to figure out how to change those. One way to kind of short circuit the entire thing is to just look at your procurement and see if 100%, what would it take for 100% of what comes into your supply chain, including heat, energy, running your data centers and materials, what would happen if those came from a secondary source instead of a primary source? Because it ends up pushing then on the market for secondary materials. And until the secondary material market grows significantly, we cannot shift to a circular economy. I see a lot of discussion happening for end of life of a product and not very much happening for the beginning. And that's where we in supply chain can make a big difference, because we can push back and say, hey, supplier, what are you doing to find secondary resource or secondary materials? And there's one more question in the chat that I'll answer, and then we're out of time. It's hard to see private sector adapting to circular economy organically. What is the role of government? Interesting. So here's the deal. If you're trying to do a circular switch and you're not making money, it's not circularity, it's a CSR project. So what we often say, there's a guy from Procter & Gamble called James McCall, and he says, this isn't charity. This is a business model. So if you've not set it up properly, you won't make money, but this is meant to be an actual strategy for your supply chain to move faster and be cheaper. You should be making more money. So the argument is a financial one. It's not a good for the planet one, actually. Both happen, but there's a tremendous amount of economic value, $4.5 trillion globally if we can unlock it, and a great business case for individual supply chains. Additionally, especially these days, it helps to mitigate a lot of the risks we see in material availability, and we're all feeling that right now. If we had more of a circular setup, for example, we would not be in the middle of a PPE crisis, because we would not have ever made those to be single use for throwaway. Each doctor, nurse, et cetera, would have a set that they would actually wash and reuse. And we've moved away from that into a land of convenience, and that has really hurt us this year. But we're out of time. So listen, thanks everybody for coming. Thanks for the questions. I hope this was interesting and opens a few new ideas for you as you complete your studies. Please do learn about this. A few academic articles are just starting to be published, so you are among the pioneers. Please look into this, and looking forward to hearing from your different ideas in the future.
Thank you. Thank you for being with us, Deborah, today.
Thank you so much.
Take care, everybody.
Thank you. Thank you so much, Deborah. Thank you.
Thank you.
Thank you.
All right. Thank you, guys. I guess we can wrap.
Thank you. Thank you for joining.
Thank you.